Alrighty, here we go. Algebra 2. 15, 16, 17. 15 is the Muckleshoot problem. Okay? The Muckleshoot problem is basically, it's not compound interest, it's just interest, okay? Based on exponential function or exponential growth. Because this is exponential growth, we're talking about A times 1 plus R to the T. Okay? And so A is the amount you start with. You have an 18-year-old who's going to invest $80,000. So the amount we start with is $80,000. Right? And then at a rate of 1 plus, and then instead of 6.5%, we're going to go 0.065. Right? Yes. Because we're moving it over 2 places. Right? So the whole. Okay? So we got 0.065, so it's 1.065 when we add it to 1, right? Okay? And then we raise it to, we got 18 years old, and he's going till he's 50. So that's 32 years. Okay? So we have 32 years is how long you're doing it. Alright? Plug it in your calculator. Clear. 80,000 times the quantity of 1.065 raised to the power of 32 equals 600 and 174.36. So 600,000. Okay? Alright, so if you wanted, you could tell me how much you're going to, if you wanted to pull out per year or per month, per year, per month. Yeah.
Is that a decimal or a dash?
This is a comma. Right?
And not the second one.
This is a decimal.
Okay.
Okay?
Decimal or dash?
Alright, and then, so extra credit, right, is telling me, hey, how much would you earn a year? And how much could you earn a month on interest if you left that amount in? Okay? So if we left that amount in the bank, but we kept it going at 0.065, that means I would take that amount, multiply by 0.065, and I would get per year
39,000.
39,000
How do you figure that out?
$11.
and 33 cents, right?
Yes.
How would you figure that out?
So you take this number and you multiply it by 0.065. That's 1 year of interest, just pure interest, right? And then what do you do per month?
Don't you divide it by 12?
Yes. So per month, okay, we're going to divide that by 12.
3,250.94.
Good. 3,250 point what?
94.
94. Good.
That's a lot of dollars.
Okay? So that means you could live off of $3,200 a month, right?
For one person?
Yeah. So when you're 50, that would be your retirement.
Holy crap.
And you would still have over $500,000 in the bank.
You could have like a really nice house with that.
Okay? Next, inverse functions. What are we going to do with inverse? What do we do with inverses? Come on, people, wake up.
Sorry, I'm writing down that one.
Inverses. What's f of x? The whole function. Good. What do we also call f of x? Y. Okay, and what do we do with x and y in an inverse? We switch them. Good. So we're going to go x is equal to 2y minus 5. And then what do? Solve it, right? So plus 5, x plus 5 equals 2y. Then what do? Divide by 2, divide by 2, divide by 2. So y is equal to 1/2 x plus 2.5. Okay? Now, how would I write that so that it says the inverse function? How do I write inverse function? This is huge. Okay? F inverse. That's f to the -1. Okay? Of x is equal to 1/2 x plus 2.5 or 2.5. Okay? That's how you would write it as an inverse. So if you see that notation on the state test, that's what they're asking you. They're asking for the inverse. That's different than this notation, right? Remember that notation? That's a derivative. Remember? The derivative. This is a negative, okay? It's an inverse. Totally different. Very important. Okay? All right. Next. How are we going to write the logarithm? Remember, if we have a base raised to the exponent and equals a number, right? Then what are we going to do? Log base of the number is equal to the exponent. Okay? That's your test tomorrow. Your test is based on that tomorrow. Okay? So, how do I rewrite this as as a logarithm? What's the base?
Oh, 2.
2. Log base 2. What's the number?
5? Oh, 32.
32. And what's the exponent?
5.
It's that simple.
So the case you just mentioned?
Yep.